Okay, thanks for joining us on the channel. Today we're going to look at a VK3AMP linear amplifier that came in. Looks like it's got an issue with with one or numerous transistors, and we're just going to quickly assess that and figure out how many we need to put in there, and we'll get the parts and we'll swap them out, and you should be good to go. I believe the reason for the damage was something to do with the operator accidentally transmitted on one band while the amplifier was switched to a different band, which is a short in the RF. It's a short circuit when that happens, so quite a bit of energy goes in and can do a lot of damage very quickly. But hopefully we've only lost maybe one transistor. It's really hard to tell. We really need to jump inside and have a look. So I'll pop the hood and we'll have a look inside and run some tests. Okay, so we've got the low pass filter board off, and I could notice that there was a bit of a smell inside the amp. It smells a little bit, something's burnt. It's very mild. I'm not sure if, it's hard to say whether or not it's just the smell of new parts that obviously, have sort of heated up at some point. Obviously the transistors get quite hot during a transmission, but it does have this very slight pungent smell, like as if something has actually burnt. I can't see it looking here. I can't see anything on top of the low pass filter board either. But I mean, there's only relays here, and of course the low pass filters themselves, the toroids, the inductors. If I just turn this over, have a look on this side. All the transistors look good. All the capacitors look good. There's no signs of burning there. Oh, here we are. Oh, that doesn't look good. Okay, so there we are. Oh yeah, that's it there. All right, so we've done the actual balance resistor, which balances between the two boards. That's blown. The balance resistor would have copped the difference in about a quarter of the power of the amplifier. So whatever was running at the time, it would have copped about a quarter of that. So that'll need to be replaced. That's not a biggie. Let's have a look at these transistors here now, test their values and see what we've got. All right. So we'll start from the left and we'll work our way across. So we're going to the first transistor from the gate to ground, 1.5 kilo ohms. So that transistor's good. 1.5 kilo ohms on the second, that transistor's good. 1.5 kilo ohms on the third, that's good. This is looking good. 1.5 kilo ohms on the fourth transistor, that's looking good. So the first board's good, no issues there. Let's look at the next one. 1.5 kilo ohms, that one's good. This side. 1.5 kilo ohms, that one's good. Oh, we're doing well. Oh, there we go, that one's gone. 10.6 ohms. So that's a short. And the last one, lucky last, 10.5 ohms, that one's gone as well. So I've lost the last two transistors. And we have lost the balance resistor on the low pass filter board. And at a guess, I would say that's probably all that's wrong. So we need to remove those last two transistors. We'll take those off and we'll replace those. We'll replace the balance resistor and everything should be good. So we'll do here. Just cut the legs off. These are very cool tools. They're from JCar, and they're reinforced nylon. Really good for lifting things up and squeezing inductors. Right, so that's one of our transistors there. I'm just lifting it off the board a bit so I can get the side cutters in there. Just clean up this we'll clean that up some more once we've got the legs of the transistors off. So I'll get the legs off first. You just heat it up and push it towards the copper. It stays on the iron. And if we just get our solder wick on there. Clean that off nice. Right, it looks good. There we are. So that's it's all ready for our new transistors to go on. So it's pretty easy, really. We replace the transistors. We use a bit of the heat compound, CPU paste, some people call it. Depends what area you're from. If you're from PC world, and we clamp those down using a special torque tool so that they're all exactly the same level, and solder the legs on, and we'll replace the balance resistor and put our RF cables back on, and should be good to go, and then we'll do some tests. So I'll be back once we've got some transistors. Okay, so here we are back today, and we've now got some transistors to actually to do the repair here on this amplifier. So let's get to it. So the first thing we're going to need to do is to reduce the size of these transistor pins because they're a bit long. All right, and the best way to gauge that is more or less just to sit a transistor in the space and just have a look, or you can mark it with a pen, which is what I like to do. So if you just put a little pen mark just on one of the transistor around about where you want to cut it, and then probably just cut it a tiny bit shorter than that position, and that should work out well because you want it to cover pretty much all of the pad, but you don't want it to overlap too far onto the board. All right, so we just snip those off, and we can sit that in there and just have a good look and make sure it's correct. And that's pretty good. Now, the transistors are marked A and B. You have to be very, very careful because they work in pairs. So the A would go on the left and the B would go on the right, and that's in each set. So you've got AB, 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 AB. So if you just put on some, I've got magnifying headset so that I can actually see up nice and close which one I'm using. And this one here is B. I don't know whether you can see that on the video or not. It might be too small, but you can see it says MHT1803B. So this one is the one that goes on the right-hand side, and of course the other one is A. Anyway, we'll get this one on first, and then we'll move on to the A transistor. Now, of course, it's the middle of winter here in Sydney, and I'm out in my garage, in my workshop, and the copper plates are very, very cold. They're almost icy. This is not going to help us too much when soldering, in particular the center pin, because the heatsink is going to draw that away. That one is actually connected on the other side directly to the heatsink. So when we try to do the center pin, the heatsink is going to try and pull all the heat away from that center pin when we solder it. So what I like to do is I just like to get a hot air gun, right, just a normal Ryobi hot air gun, and I just place it about, not too far, maybe 2 inches from the exhaust vent on the amplifier, which is on the left-hand side, and I just turn it on and just start to warm the copper up. So it'll warm the heatsink up, and the copper will start to warm up as well, and that'll make it much easier for us to put that center pin on. You don't have to go too far. We're not trying to get this red hot or anything like that. We don't want to damage any of the components. For the most part, we're just trying to really take the chill off it, and by doing so, it should ease how much heat we need to use to actually solder the component on, the device on. So I'm just going to do that. I'm not going to do it whilst I'm on camera here. I'll just pause the video because it's very, very noisy, and you probably won't be able to hear what I'm saying. So I'll just turn that on. We'll heat this up until it's maybe 35 degrees, something. You should still be able to touch it, but it should feel nice and warm to the touch. And then you can stop the fan, and hopefully your soldering will be much, much easier. So I'll just quickly do that now. So you can hear how noisy that is, but it will quickly warm everything up, and then it'll be good. So I'll come back in a minute when it's nice and warm. Okay, so here we are back again, and that took about 3 or 4 minutes to get the copper warm. You can certainly hold your hand on there for as long as you want. It's never going to burn you. It's not that sort of heat we're trying to get. We're just trying to take the chill factor off it. So the first thing we need to do before we start soldering the device on is we need to add some heat compound to the bottom so we get a good contact with the surface of the copper. And we also want to bend our pins down ever so slightly towards the copper plate, and that will just make sure that when we're soldering, it's much easier to get a connection. If they're sitting off the plate, you're going to have to fill up all the underside of that, the legs, when you solder it, which is it's not going to be a problem, but it'll just be much easier and probably get a much better connection if we bend them down a bit. And you don't want to go too far, because when we actually screw the device down, we don't want any pressure pushing back on the ceramic via the pins, because there's a possibility, it's probably remote, but there is a possibility that you could crack the transistor as you apply pressure to it. So as I said, the next thing we need to do is to put a tiny little bit of heat compound on there. I'm using MTG10 as recommended by Onda, and you only need a very, very small amount, just a little dot of it. All right, and we just spread that out over the whole transistor, with a spatula or anything you've got there that's handy that will spread it out evenly. All right, so as long as you've got good coverage on the whole flat surface of the transistor, it should be good. I'm going to go OCD, of course, because all right, so we've got the whole transistor covered in the heat compound, and then we can place the device onto the board and line it up with our pins. And the next thing we need to do is to screw the transistor down. And of course, we do that using a torque wrench or a torque screwdriver because we want to get the same pressure onto all of the transistors, so they're all evenly pressured down onto the board. All right, so I'm using a torque screwdriver, and we're doing this at 0.09 Newton meters. You can see there, 0.09 Newton meters. So that will release when we get to that pressure. So let's push that through. And do it very gently. It will release, but we don't want to damage the thread in the copper. Hopefully you can see me doing that. The other thing I'm trying to do at the same time is to keep the pins aligned with the pads on the circuit board. We want to make sure that they are in line and good for soldering. Okay, so now that's good. So when I tighten that now, it releases, and I can't tighten it anymore. So that's the correct pressure we want. And then, of course, we solder those down to the board. All right, here we go. It's one. That's two. And the center one will typically be the harder one to do of the three. It takes quite a lot more heat to get a good contact. So just be prepared for that, because that is definitely going to be a small issue that you'll have to face. So that's one of our transistors on, and we can do a quick check to make sure we have good contact. Once again, using our ohm meter. And of course, we're looking for 1.5 kilo ohms from the gate to ground. So on this pin, it's the outside one. .5 kilo ohms. All good. So now we can move on to the second one. So it's just the same process once again. Don't be afraid to hold it on there. The heatsink is pulling the heat away, so you're not going to cause any damage to anything by getting it hot. It's not really getting any hotter than the other two are. It's just they happen quickly and it takes a long time because the heatsink wants to keep drawing that heat away. And again, we do a quick test. And this time we're going from this side, because the gate is over this side of the transistor, and we're getting 1.5 kilo ohms. So there we go. That's how we replace the transistors in a VK3 amp. So the only other thing we need to do now is I'm going to replace the balance resistor on this board. So I'll quickly do that. So this is actually the balance resistor as it comes. I just need to remove the ring hole, the top section, so there's just a small amount of solder plate there, and shorten the legs to go on the plate. So I'll just quickly do that, and I'll come back. Okay, so you can see here now I've modified the resistor. I've shortened the legs and removed the ring pin at the top just to give us a small bit of plate to get the soldering iron on. I'm just going to put some solder on this pad, all three pads, and then we can start applying some heat from the top, and it should weld itself down to the whole thing. So I'll just hold that in place with something, just to keep it where I've got it, whilst we get the legs to attach. That's the legs on, and that'll just keep it in place, and then we'll apply some heat and some solder to this plate section here that's left over. And that should transfer the heat down to the underside. There we go. Alright, so that's our balance resistor attached to the board. So I'll be back and we'll start first with setting the bias. Okay, well, we're all set up now here to do the bias, and I'm going to do this in two parts. The first video, I need to actually hold the camera and move around and show you how it's connected, and then the second one, we'll mount the camera and we'll actually go through the process of adjusting the bias on the devices. So the first connection you're going to need to have is the positive from your 50 volts power supply, and that needs to come around to the front of the amplifier on the front right hand side. You'll see that there's a yellow connector in the board. If you take that connector out and we want to connect it to the top pin, so this pin here where the shape of the connector changes, so we're using that top pin there, and that's where we connect our 50 volts power supply. Alright, so I'll just quickly do that. I might do a drawing. I might just do a quick drawing as well, and I'll pop that up on the screen to show you the actual connections. I'm just going to turn the power supply off for a second, although it's actually not putting out any voltage at the moment. I've got it on standby, so I'll just connect this up. I'm trying to do this one-handed, so bear with me. Alright, so we've gone to the top pin on there. You can see how the pin changes. So that is coming from our 50 volts power supply. And then the earth wire from the 50 volt power supply just simply gets attached to a part of the chassis, so any ground section. And in this case, it's probably just best to use the some of the lugs there that are holding the copper onto the heatsink. Alright, so that's your 50 volts connection. The 12 volts connection, same deal. So our positive wire, we come around here and we connect it. And if you look at the board B, I suppose you could call it, the right-hand side board, unlike the left-hand side board, the right-hand side board has this connector. And if we go to the bottom left pin, all right, the bottom left pin on the left-hand side, that's where we connect our 12 volts to. Alright, so I'll just turn the power supply off when I connect it so we don't bump any pins or anything like that. Alright, and just be careful with the pins and just have a good inspection and make sure that it's not touching any of the other pins, that you're only actually connecting that particular pin. Alright, so the bottom left-hand one. And once again, your earth wire gets attached to the chassis. Alright, so both ground wires get attached to the chassis, and just use, as I said, the lugs on the copper plates there on the heatsink. And your positive goes to the bottom left-hand one there for 12 volts, and your 50 volts goes to the top connector on there. Just remove it from the control board below. Alright, so I'll just set up now, and we will run up and we will actually adjust the bias. I'll be back. Okay, so here we are back with everything wired up for the bias test, or for the bias configuration. And what we're going to do here is we're going to supply 50 volts and 2.5 amps of current to the circuit. And you'll notice when we turn the power on, we should be seeing 50 volts. All right, we've got 50 volts being fed. But we've set it up for 2.5 amps, and the reason we don't want to set it for 2 amps is because as we set the bias and we approach 2 amps, which is what we want our final value to be, the power supply is designed that if the amps start to get reached, it reduces the voltage, which we don't want to happen. So even though we're only aiming for 2 amps total across all 8 transistors, we set the current setting to 2.5 so that we don't get a voltage drop as we get close to it. On the board, on each of the 2 boards, you'll find 4 blue pots, like a little block with a brass screw on it. These are our bias adjustment blocks. And before you start adding your voltage, you need to turn the screw counterclockwise perhaps 5 or 6 times to make sure that they're completely off. You'll know if they're all off because when you supply your voltage, you will see 0 amps current being drawn. If you see any amps being drawn at all, even if it's just 0.1 or 0.2, then one of your pots is not turned all the way off, and you risk getting your bias out of whack, which we don't want to happen. So make sure that you've got 0 amps on your circuit when you start to turn your pots. All right, so we're going to start on the left-hand side. I'm sorry you can't see the first 2 pots, but I assure you they're all the same. And I'm going to start turning the pot clockwise until we get 0.25 amps on the power meter. All right, so I'm going to do that now, and they're just very, very small turns. You don't want to turn too quickly. All right, and I do apologize. The camera is going to try and focus on the screwdriver for these first couple, but as we move along, the power supply will be nice and clear in the video for you, so just bear with me. All right, here we go on the first pot. So tiny little screw, put the screwdriver in there, and I'm turning it clockwise, just a small amount. Here we go, and you can see there the amps are starting to come up. So 0.3, 0.7. All right, we're going for 0.25, 19, 20, 21, 3, 24, 25, 0.25, and I'm just going to turn it, no, gone a little bit too far, 0.26. I'm going to come back, tiny movement here. We're talking, you know, fractions of a millimeter. I'm just going to bring that down a smidgen. Interesting, it's going up. I'm turning it to counterclockwise. Okay, 0.25, 0.24. Turning it ever so slightly counterclockwise until we get to 0.25. There it is, 0.25 amps. All right, 0.25 amps, 12.5 watts. Oh, that's still dropping down to 0.24, so let's just tiny little movement clockwise to stabilize that. Okay, so it's good to pause between them all and just make sure that it remains stable before moving on to the next one. All right, so that looks pretty good. That's holding well at 0.25. We're not seeing any changes there. So we'll move on to the second one. Here we go, turning it clockwise. 0.26, 7, 8. All right, and we're going for 0.5. 0.48, 0.49, 0.50, and I've just turned a tiny little bit there to make sure, no, that was too far. So going counterclockwise just a smidge. All right, 0.5. And we just pause there for a little while just to make sure it stays stable. Okay, looks good. Let's move on to the third one. .51, and we're aiming for 0.75 here, of course. Nope, too far. .75. Looks good, seems stable. Moving on to the fourth one. We're aiming for 1 amp here now. A little too far. 1 amp. Looks good. Let's move over to the next board. I'm going for 1.25 amps. It's very sensitive. There we are, 1.25. Number 6, going for 1.5 amps. Looks good. Number 7, going for 1.75 amps. Oop, too far. And of course, last but not least, number 8. And this will give us our full 2 amps draw. There we are. Now if we had the power supply, I should say, set to 2 amps, what would happen here is the voltage would start to drop. Alright, so that's not dead stable there. Let's just wind that back a tiny little bit. Two amps stable, 100 watts. Alright, still ticking over to 0.01, so let's come back a tiny bit more, just keep an eye on that one. And that looks good. No, still wants to trickle. What we'll do is we'll drop it down to 1.99 and then very, very, very slowly bring it up to 2. Oh, gee, it's sensitive. Let's see how that goes. And that's looking good. So there we are. We've got 2 amps draw across all 8 transistors at 50 volts, 100 watts. And that is our bias set. So all there is left to do now, of course, is to put the low-pass filter deck back on, and then we can move over to testing the amplifier into a dummy load. So I'll be back very, very soon, and we'll do a test. Okay, now we're going to, we've finished doing all the work on the amplifier, so now we're going to test it. And we're going to transmit into a dummy load so we can not worry about where we're transmitting on bands or anything like that. Just fire away. I'm going to look at the output power both on the LP500, which of course is a very accurate power meter, and also the software here, and we can get a comparison of the difference between the two. There will be a variation, probably plus minus 100 watts. Hopefully the LP500 shows us a power level that is higher than what the amplifier shows, and that just means that we're reaching those power levels much sooner. And you know, I believe there is some settings that can be done to adjust it, but I'm not going to attempt that on this particular case. All right, so here we are on, we'll start with 160 meters and we'll work our way up the band. I'm going to start with about 10 watts drive here, and I'll just use CW to transmit, and then we'll do a little bit of single sideband on the band as well, just to look at the two different types of carriers. So here we are, so we'll do CW first. And you can see there that there is actually, in fact, 100 watts variation. Almost exactly. So 1500 on the meter and about 1425. Well, a little bit of a difference is changing. Anyway, that's okay. Let's have a listen to that, look at that on single sideband. Testing, change to single sideband. Testing 1, 2, 3, 4, 5. Victor Kilo 2 Papa Whiskey. Testing 1, 2, 3. And let's bring the power up now. Testing 1, 2, 3, 4, 5. And I'm watching the LP500 till it gets to 2 kilowatts. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we are. So there's 2 kilowatts there. So not a big difference between the radio and that. They're pretty close. Very, very close indeed. And CW again. Okay, so there we go. That's 160 meters. Everything's looking good there. Let's move up to 80 meter band, and 3560 is good. I'll change the band on the amplifier. All right, and we'll do the same thing. I'll reduce this power down to 10 watts will do. Must remember to change that. It doesn't matter if we're on upper sideband because we're on dummy load. So not a great deal of difference there between the two, only about 35-40 watts in this case. Let's keep going. You can see there about 1838, so quite a difference there once we get up with some power. And the goal here is to make sure that we're getting 2 kilowatts out. And we're doing that on the LP500. There we go. So 2 kilowatts, no problem there. And let's go to sideband. Testing 1, 2, 3, 4, 5. Testing 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 on 80 meters. There we go. A little bit extra drive there, and we've got our 80 meters, 2 kilowatts. So all's good there. All right, let's go to 40 meters. 40 meters. And it doesn't matter where we are because we're on the dummy load. Okay, I'll reduce this down to a reasonable amount. We'll do CW first. We'll follow it the way we've been doing. Here we go. All good there. That's about 1 kilowatt. That's all good there. 1800, 1900, so about 32. 1994. And you can see there's our 2000. So a bit of a difference between the two, but that's not too bad. And on single sideband, testing 1, 2, 3, 4, 5, testing 1, 2, 3, 1, 2, 3, 4, 5, and we'll get a bit extra drive there, and that should tip us over. Testing 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3. So I have a limiter set here to 45 watts drive, so I don't ever go over on 80 meters on my own. Anyway, there we are, testing 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's close enough.
20 meters. Actually, sorry, we'll do 30 meters. Things as we've got the dummy load. I can't do 30 meters into my step IR. I can do it into my wire antenna, but anyway, here's 30 meters, and we'll just turn this down again. 30 meters selected on the amplifier. All good there. All good. I think I'm going to run out of drive power before we get there. Okay, so the way I can resolve that is if I go to my PA settings here, on 30 meters, so I'll just talk on single sideband here, and what I do is if I reduce the attenuation, it'll come up again. Testing 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's pretty good. That's pretty good. All right, let's go to let's go to 20 meters. Turn the power back down again. And I'm going to cancel this because I don't want those settings to save. Testing 1, 2, 3, 4, 5 on 20 meters. 1, 2, 3, 4, 5 on 20, bringing it up, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, there we are, there's our 2 kilowatts, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so we're good there, and the meters kind of agree reasonably well, plus minus just a little bit, not too much at all, only about 50 or 60 watts difference. Testing 1, 2, 3, 4, 5. And we will do some CW. And we're getting about 2200 watts out, so all good there. Let's go to 17 meters. We'll do this on 18100. CW, we'll do CW first. No problem there. We can probably double that. A bit more. It's good. There's our 2 kilowatts. And the meter agrees, plus probably about 100 watts difference. Single sideband here, testing 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, absolutely no problems there. So we can look, if we bypass the amp, we can see here on the meter how much power it's running. So it's taking 24, almost 25 watts to produce that. You can see there's a big difference in the calibration, but that's because my attenuators are on. So in actual fact, it's actually only doing 25.2 watts. And that 25.2 watts is producing QRO. Let's go to 15 meters. We don't need to change the amp because 17 and 15 are together. So here we go. Let's testing 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Testing 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we are. There's our 2 kilowatts. Testing 1, 2, 3. Hello radio. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the metering is not too far out actually on this band. Pretty good. Pretty close. In CW, pretty good. Probably come up 1 watt and get the 2K. Maybe a little bit more. There we go. 2 kilowatts. Testing 1, 2, 3, 4. Sorry, I don't know why I'm talking. So that looks good. Everything's good there on 15 meters. Changing band on the amplifier and coming up to 12 meter band. I'll turn this back down. We're on CW. We'll go back to sideband. Testing 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Testing 1, 2, 3. Looking at the LP 500. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so again, my attenuation is set to restrict on 12 meters. So if I drop this down, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Testing 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that's about what we're going to get there on 12 meters. Testing 1, 2, 3. And CW, no problem there. There's your 2 kilowatts. 10 meter band. 28.490. I'll just move that away. We don't need that there at the moment. 28.490, and we don't need to change the amp because they're both on the same band. We're on single sideband, testing 1, 2, 3, 4, 5, testing 1, 2, 3, looking at the LP 500, 1, 2, 3, 4, 5, there we are, there's our 2K, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, looks like it's going to go, no, that's okay, that's to be expected, a little bit over, testing 1, 2, 3, 4, 5, testing 1, 2, 3, 1, 2, 3, 4, 5 there, and quite stable at about 2.1 kilowatts. And on CW, all good. Okay, let's go to 6 meter band, 50.313, and we select 6 meters on the amplifier. We're on CW, we'll start there. That's all good. About 800, 1300. 14, 16, 17. I do have a limiter on 6 meters, so we may not get there. Oh yeah, we probably will. Okay, so that's pretty close. All right, and we will do some sideband. Testing 1, 2, 3, 4, 5. Testing 1, 2, 3. You can see there on the LP. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I think my limiter is engaging now, so I might change it. That's fine. Let's play. Oh, there we go. There's your 2K. So there we go. Everything is looking good on the amplifier. I think that was a pretty successful operation, and hopefully the owner won't have any more problems. There will be a cable going out for him, so he'll be able to automatically switch the bands, and hopefully his troubles will be behind him. Everything seems to be working well from this end. Thanks for watching. Hope this video was of a great deal of help. This is Victor Kilo 2 Papa Whiskey.